हेलो स्टूडेंट्स, इस वीडियो में मैं आज आपको कुछ और इंटीग्रेशन के ऊपर बेस्ड प्रॉब्लम को सॉल्व करना बताऊंगा। तो इसमें जो फर्स्ट क्वेश्चन अपने को सॉल्व करना है उसमें गिवन में है इंटीग्रेट 1/1 माइनस साइन एक्स विद रिस्पेक्ट टू एक्स। सो टू सॉल्व इट इन नेक्स्ट स्टेप वी विल राइट इंटीग्रेट 1 डिवाइडेड बाय 1 माइनस sin x dx. So it is clear from this question it cannot be integrated directly. So here to integrate this one we will use 1 divided by 1 minus sin x, then we will multiply it by it in denominator as well as in numerator by 1 plus sin x divided by 1 plus sin x dx. Now next step it will be integration of 1 plus sin x divided by 1 minus sin square x dx. Now next step it can be written as 1 plus sin x divided by cos square x, because the value of 1 minus sin square x will be equal to cos square x dx. Now next step it can be written as integration 1 divided by cos square x dx plus integration of sin x divided by cos square x dx. Now in next step it can be written as integration of sec square x dx plus integration of sec x tan x dx, because in place of sin x divided by cos square x it can be written as 1 by cos x sin x divided by cos x. Using the trigonometry, in next step we will write sec x tan x. So to solve this integration we will use trigonometry, the formula used in trigonometry. So next step, now the integral coefficient of sec square x, that will be tan x, and the integral coefficient of sec x tan x, that will be sec x, plus c constant of integration will be also there, so that will be the integral coefficient of the given function. Now next problem, integrate sec raised to over 4x tan x dx. So it is another different type of the problem. To solve it we will write sec cube x sec x tan x dx. Now we will solve this one by the substitution method. So let sec x is equals to t, as we differentiate t, dt divided by dx, we get sec x tan x. So the value of dx written as dx is equals to dt divided by sec x tan x. Now use these substitutions in the given function. So we get t raised to over 3 sec x tan x. In place of dx we will substitute dt divided by sec x tan x. These both will be cancelled out, so there will be only t raised to over 3 dt. Now it can be integrated very easily. Its integral coefficient will be t raised to over 4 divided by 4 plus c. Now we will return the value of t, so we get sec raised to over 4 x divided by 4 plus c. So that will be the integral coefficient of the given function. Now next problem, integrate sin square x with respect to x. So this is very common integration and will be used frequently in physics. So to integrate this one, we will use trigonometry. By the trigonometry, as we know that cos 2x, it can be written as cos square x minus sin square x. Now next step, we can substitute 1 minus sin square x in place of cos square x and minus sin square x. It can be written as now 1 minus 2 sin square x. The value of 2 sin square x will be 1 minus cos 2x. So the value of sin square x written as 1 minus cos 2x divided by 2. So this is the substitution we will use in this function. So from equation 1 and 2, we can write 1 minus cos 2x divided by 2 dx. Next step can be written as 1 by 2 dx minus 1 by 2 integration of cos 2x dx. Now for dx there will be only x, so this is x by 2. Now here 1 by 2, the integral coefficient of cos 2x, that will be sin 2x divided by 2. Constant of integration will be also there. So finally we have x by 2 minus sin 2x divided by 4 plus c. That will be the integral coefficient for the given function. In next problem, we will integrate cos square x with respect to x. So the similar concept we will use in this problem also, because we have cos 2x is equals to cos square x minus sin square x. The next step, cos 2x is equals to cos square x minus 1 minus cos square x. We can substitute in place of sin square x 1 minus cos square x. Simplify it. So we get cos 2x is equals to cos square x minus 1 plus cos square x. So it will be 2 cos square x minus 1. Now the value of 2 cos square x is equals to 1 plus cos 2x. So cos square x written as 1 plus cos 2x divided by 2. This is the substitution we will use in the given function. Now this is equation 1 and this is equation 2. From 1 and 2 we get integration of 1 plus cos 2x divided by 2 dx. Now next step is 1 by 2 integration of dx plus 1 by 2 integration of cos 2x. Now integrate. So integral coefficient of dx will be x, so that is x by 2 minus, because the integral coefficient of cos 2x will be minus sin 2x divided by 2, so it is sin x divided by 4 and constant of integration will be also there. So this is the integral coefficient for the cos square x with respect to x. Next problem, we will integrate cos square x by 2 with respect to x. So a similar concept we will use. ऐसा ऊपर यूज किया था वैसे ही करना है. इधर उधर cos square x था, इधर cos square x by 2 है. अब देखो क्या करेंगे. As we know that cos x, it can be written as cos x by 2 plus x by 2. So now in next step, that will be cos square x by 2 minus sin square x by 2. Now to find the value of cos square x by 2, can be written as cos square x by 2, and in place of sin square x by 2 we will substitute 1 minus cos square x by 2. Now simplify it, so there is 2 cos square x by 2 minus 1. This is the value of cos x. Now the value of cos square x by 2, that will be 1 plus cos x divided by 2. So this value we will use in place of cos square x by 2 in the given function. So there is integration of 1 plus cos x by 2 dx. Now integrated will be 1 by 2 integration of dx plus 1 by 2 integration of cos x. It's so simple to integrate now. It will be x by 2 plus integral coefficient of cos x will be sin x, and sin x divided by 2 plus c. Constant of integration will be there because this is indefinite integration. Next problem, we will integrate tan x. To solve this integration, we will use trigonometry. By the trigonometry, in place of tan x, we will write sin x divided by cos x dx. Now next step, that cos x is equals to t, the value of dt divided by dx will be minus sin x. So in place of dx, we can substitute minus dt divided by sin x. Now use this substitution in the given function. This one, there is integration sin x divided by t, and in place of dx, there is minus, so minus, this is minus dt divided by sin x. Sin x will cancel out. The next step, we have only integration 1 by t dt. So integration coefficient of 1 by t with respect to t, it will be minus log t plus c. Constant of integration will be there. Now we will return the value of t, so we get minus log, in place of t there is cos x plus c. Now using the properties of logarithms, can be written as log cos minus 1 x plus c. Now cos minus 1 means 1 by cos x, that will be sec x. In place of cos inverse x, we can write sec x plus c. That will be the integral coefficient of tan x. In next question, we will integrate log x with respect to x. This is little bit a tricky question. इसमें थोड़ा सा ट्रिक लगाना पड़ेगा. देखो क्या करेंगे. अब 1 से मल्टीप्लाई करके लिख सकते हो. इट कैन बी रिटन एज log x multiplied by 1 dx. Now there are two functions, log x and 1. So by the rule, log will be considered as a first and 1 considered as a second. So it can be now solved by the formula of integration by part. First function means log x, then integral coefficient of second, integral coefficient of 1 with respect to x, so it is 1 dx. It can be simply write down dx also, and minus integration d divided by dx means the derivative of first function log x then the integral coefficient of second dx, and we integrate all again with respect to x. Now solve it. Log x, integral coefficient of 1 with respect to x, that will be only x, minus integration derivative of log x will be 1 by x, and the integral coefficient of 1 with respect to x, that will be x, so it is written as x. Now integration of all. The next step we write x log x minus this x, and this x will cancel out, so there will be only dx. Integral coefficient of dx with respect to x will be 1, and plus constant of integration. Integral coefficient of 1 with respect to x will be x, and there will be also a constant of integration, that will be the integral coefficient of log x. Now in next problem we will integrate e raised to power sin x into cos x dx. This is one more example of the integration by the substitution. Here let sin x is equals to t. The next step, the value of dt divided by dx, it will be cos x. So we can substitute in place of dx dt divided by cos x. Now substitute these values. We get integration e raised to 1t cos x dt divided by cos x. Cos x cos x cancel out. There will be only e raised to 1t dt. Now its integral coefficient will be also e raised to 1t plus c. Now return the value of t. So this is e raised to 1 sin x plus c. That will be the integral coefficient of the given function. Next problem, we will integrate x log x dx. This is an example of integration by parts. So by the rule, log x considered as a first function, x will be considered as a second. So now using the formula of integration by parts, we will write first function means log x and integral coefficient of second, so x dx, minus integration d by dx of first function means log x, and integration of second means x dx, and integration of whole. Now solve it. So it is log x, integral coefficient of x will be x square by 2 minus integration derivative of log x will be 1 by x, and integral coefficient of x will be x square by 2 dx. Now further solve it. So it is x square log x divided by 2 minus integration x divided by 2 dx. Now as we solve, we get x square log x divided by 2 minus x square divided by 4 plus c. So that will be the integral coefficient of the given function.
Please like and subscribe to Physics 21 and keep watching. To download note in PDF format, link given in description. See you again.